Hello everyone, this is Dr. E, and for today we're going to learn the difference between deductive reasoning and inductive reasoning. From our previous lesson, we learned about inductive reasoning, and inductive reasoning is based out of several conditional statements or examples or patterns so that we can arrive to a conclusion which we call as conjecture. Now, what is the difference between inductive and deductive reasoning? By definition, deductive reasoning is the process of proving a specific conclusion based out of one or more general statements. Now, a conclusion that is proved true by deductive reasoning is what we call as a theorem. And that is the formal definition of deductive reasoning. And to give you a better idea on the difference between deductive and inductive reasoning, let's review what it means by inductive reasoning. This is a type of reasoning wherein we observe patterns or examples and then use them to form a general conclusion that may or may not be true. So that is the difference between deductive and inductive reasoning. And from our examples from our previous video, we know that in a number pattern, seeing that we have 3, 6, 9, and 12, and if we're going to predict the possible number after 12, we can say that it's going to be 15 because what we're seeing from the pattern is that we have a multiple of 3 in our sequence of number that we are seeing in our example. So what we just did to figure out that the next number after 12 is 15 is inductive reasoning, and this is the conjecture that we're able to formulate because this may not be true all the time because we are just basing our prediction based on our pattern. Now, to get a better idea on how we perform deductive reasoning analytically is using the law of detachment. This law of detachment is basically one way on how we'll be able to use deductive reasoning in mathematics. So let's say if P then Q, which is a conditional statement, is a true conditional statement and P is true, then our conclusion Q is also true. So knowing that we are given a conditional statement and it is an assumed true statement, when our hypothesis is true, then our conclusion will also be true. Now let's have an example so that we'll have a better understanding of the meaning or what it means by the law of detachment based on our definition. Using the law of detachment, we're going to make a true conclusion, and this example is if you shop at Save Market, you will save money. So our hypothesis here would be you shop at Save Market, which is our P. The hypothesis part of our conditional statement, and you will save money is our conclusion. Now, with the assumption that this particular statement is true, and with the statement that is formed by P then Q, therefore, the true solution here or the true conclusion here is that you will save money every time you shop at Save Market. Of course, provided that this statement is indeed true. And to give you a better understanding, we need more examples on how we use law of detachment. But as you can see, we are basing our true statement based on the assumption that our conditional statement is true. So in this case, we're going to tell whether each reasoning is valid using the law of detachment, assuming that the first statement, which is P then Q, is true. And the first statement that we have here is that if any student gets an A on a final exam, then the student will pass the course. So that is our first statement that is assumed to be true. And our example based out of this statement is that Leo got an A on his final exam. So he will pass the course. Now, is this a valid argument according to the law of detachment? Knowing that our hypothesis is a true is part of a true statement, which is any student gets an A on a final exam with the conclusion that the student will pass the course. Therefore, in our example, Leo got an A on his final exam, then he will pass the course is also true. And in this case, using the law of detachment, because we assume that our original conditional statement is true, then our conclusion in our example is also true. So this is how we use law of detachment by proving that our statement is a valid conditional statement or a valid true conditional statement. So let's have another example on how we use the law of detachment in this particular statement. So let's say that if two angles are adjacent, then they have a common vertex. That is our initial statement that is assumed to be true. And from here, using P or our hypothesis that two angles are adjacent and Q sharing a common vertex, which is our conclusion, and this is in the form P then Q, let's see if the example statement down below is a valid argument for this statement. And our example is that if angle 1 and angle 2 share a common vertex, so the angles are adjacent. So let's see if this particular example is a valid conditional statement or true statement using the law of detachment. How are we going to do that? Let's have a diagram here that similar or would make our initial statement true. These are angle 1 and angle 2. They are adjacent and they both share a vertical axis or vertex. So therefore, we are seeing that our argument is somehow true. But in this example, if angle 1 and angle 2 share a common vertex, so the angles are adjacent. Knowing how we formulate a true statement or classify a true statement from a false statement giving a conditional statement, let's see if we can produce a counterexample of our hypothesis, this hypothesis, that will give us a false conclusion. So given a true hypothesis and a false conclusion, let's see if we can do that. Angle 1 and angle 2 share a common vertex. And what if angle 2 is positioned in this part of our circle? And you are seeing that they still share a common vertex, but they are no longer adjacent. So we're able to produce a counterexample based on the hypothesis and conclusion from the main conditional statement. Therefore, we can say that the argument is not valid because using the law of detachment, we're able to prove that this example is not a valid argument based on the initial statement that we have in P then Q. So this is how we articulate and use the law of detachment by working with hypothesis and conclusion in our statement. So in your Numberbender challenge for today, let's see if you can say that this particular example, the number 11 is prime, is a true statement based on our initial assumption that if a number is prime, then it has exactly two factors. So this is your Numberbender challenge, and you can comment down below and see if this argument is true, and make sure to use the law of detachment to argue whether you have a valid statement or not a valid statement. And this is our lesson on geometry, and we've learned now the difference between inductive reasoning and deductive reasoning. And we know that inductive reasoning is basing our conclusion from our pattern, which we now call as conjecture instead of conclusion, because sometimes it's true, sometimes it's not true. But in deductive reasoning, this is when our conclusion becomes theorem, because we're basing our conclusion from series of statements or facts that we can have in different arguments that we're going to be encountering in geometry. And this is Dr. E, and see you again next time. Bye!